Hi everyone, and welcome back to another episode of Science. In this episode, I'm going to be teaching you some of the basics involving energy. We're going to be looking at the different types, the different kinds of energy that we experience here on Earth and throughout the whole universe, actually. We'll start with a definition first, though. So energy is the ability to do work. We use energy to do some form of work. And that's not just the school work that I'm talking about, but any kind of movement, for example. Anything that you can observe happening, energy is being used to do some sort of work. Let's have a look at this definition as well. Work is the effect that comes from using energy, the ability to make something observable, measurable, happen. So if you like, you can pause the presentation as I go along and take down any notes that you feel are relevant. Definitions are always really good notes to start off with. But for now, let's keep going. We'll start with some interesting questions to ask ourselves, and by the end of either this PowerPoint or this topic, I'm hoping that we can answer these questions together. So, why do you get hot when you run? What the energy stars on your fridge means? How a hybrid car works? Does energy have mass and take up space like atoms? Can energy be created or destroyed? So we'll be able to answer some of these during this lesson and more in the lessons to come. But before we go, consider to yourself, can you answer any of these questions? Okay, let's have a look at a couple more questions, a couple more scenarios before we get started. When you drop a tennis ball to the ground, why doesn't it bounce back to its original height? Do you know the answer? If not, then this lesson is for you. How does ceiling insulation keep your house warmer in winter and cooler in summer? How do glow-in-the-dark stickers actually work? How does the didgeridoo player create its unique sound? All of these scenarios are involving energy and energy transformations and energy transfer. And this is what we're going to be learning about in our energy topic. So let's get started with the content. So on this slide, I've got types of energy that I want to teach you in this lesson. Let's start with basics. First off, all things possess energy. So everything that you see around you, even if it's a Lego brick, for example, right? Any object that you can pick up has energy stored within its atoms, within its bonds. So all the things around you that you see, all things possess energy. Second one, really important with the universe. So the universe has particular laws that we have to follow. One of those laws is the law of conservation of energy. This law states that energy cannot be created or destroyed within the universe. So all the energy that we have at this moment will be the same tomorrow, and it was the same yesterday. The universe does not create new energy, and it does not destroy any energy. What it does do, though, is it can transform energy from one form to another. For example, electricity being used to generate light. Electricity is transformed into light. And you can also transfer energy. So, for example, transferring heat energy from one object to another. So it can't destroy or create energy, but the universe allows for energy transformation and transfer. And we'll look at specifics of that during this lesson as well. Next point, I've already touched on it. Energy can be transferred to another object or transformed into a different form. So these two dot points link quite nicely with each other. And the final point that I want to make right now is energy can be stored. And the most familiar way that you may have with energy being stored is in the form of a battery. A battery has chemical energy that it is storing. And we can convert that chemical potential energy into electricity. Let's move our eyes to the right of the screen now. There's two main types of energy that I want to teach you today. The first is potential energy, and the second is other types of energy that you're actually probably going to be familiar with. So let's start with what you are familiar with. We have kinetic energy here, and you might not have heard of this word before, but kinetic energy is energy possessed by objects that are moving. So if you are moving, you have kinetic energy. When a car is driving, the car has kinetic energy. When you throw a tennis ball, you give the tennis ball kinetic energy. So anything that's moving possesses kinetic energy. The next one is heat. So all of us will probably use a heater of some type during our cold winter months here in Melbourne. And heat energy is something that you can feel on your skin. Light energy. So when you turn on the switch on your wall or on your lamp, it converts electricity from your wall socket into light energy that you can see with your eyes. If you're listening to music, electricity can be converted into sound energy that you listen through headphones, and you can experience sound energy through your ears. Let's come to the column that you're probably less familiar with, and that's potential energy. So there are different ways to store energy, and that's what I want to teach you in today's lesson. The first one is gravitational potential energy. So if you've got an object around you, pick it up off the table or whatever you're sitting at. When you lift that object off the table, you give that object gravitational potential energy because you've lifted it off the ground. And if you let go of that object, gravity will pull it back down towards the Earth's core. So anything that you lift up off a surface, you are giving gravitational potential energy. Gravity wants to push it down back towards the Earth's core. And I'm going to go through a specific example where gravitational energy is involved. The next one is elastic potential energy. So when you stretch an elastic band using your muscles, that elastic band becomes stretched and you've stored elastic potential energy within that elastic band. Once you let it go and it goes flying off your finger, that elastic potential energy is released and it is transformed into kinetic energy as it flies away. You may also hear a sound, and it even gets a bit warmer as well. The third potential energy is chemical. So chemical potential energy is stored in the form as batteries, for example. Batteries have got chemicals within them that can store and hold energy. The next one is nuclear. So the sun uses nuclear fusion to power itself. It's the reason why it's so hot. Atoms themselves, they've got lots and lots of energy stored within them. So when you break the nucleus of an atom, you release lots of energy. Or when you smash two atoms together during fusion, you can also release lots of energy. So atoms themselves store nuclear energy. We've also got electrical potential energy. And that's energy supplied to homes by power lines and available to your appliances via power outlets in the home. Okay, so what you can do is you can pause on this screen and just take any relevant notes that you may need. So if you didn't know these 4 dot points, note down these 4 dot points and take notes of each of the potential energies that we have, and also the other types of energy that you are probably familiar with. Let's keep moving. Okay, so let's have a look at a specific example, bouncing on a trampoline. So when a person bounces on a trampoline, they go up into the air. When they go up into the air, they've created gravitational potential energy that wants to push them downwards. And as gravity pushes them downwards, gravitational potential energy, some of it's converted into kinetic energy as you fall back down towards the trampoline. When you land on the trampoline surface, the trampoline itself, it bends, it warps, it's quite elastic. And you've also got springs on the side here that also stretch and store elastic potential energy as your kinetic energy lands on the trampoline surface itself. So you convert the kinetic energy that you have as you fall into elastic potential energy into the trampoline surface and springs, and then that elastic potential energy shoots you back up into the air and converts back into kinetic energy. So up the top here, there's quite a neat flow chart. All right, we've got gravitational potential energy when you're at the top of the jump, converts into kinetic energy as you fall back towards the trampoline. The trampoline stretches, the springs stretch, and your kinetic energy is transformed into elastic potential energy. And then that elastic potential energy is released and transformed into kinetic energy as you fly back up into the air, and then you generate more gravitational potential energy. You also use the muscles in your legs to generate energy. So you convert the chemical energy that's in your muscles into kinetic energy, where you go to actually physically use your muscles and jump off the trampoline as well. If you're not sure what's happening here, pause the video and read these notes in your own time as well. If you still don't understand, of course, come and speak to me in class. Let's take another step forward. Okay, so here's another couple of energy flow diagrams, and I'll ask you to draw these flow diagrams in class as well. Right, so nice easy example that I've just gone through. We've got gravitational potential energy, so an object that starts off the ground, converts into kinetic energy, and when it lands on the ground, it actually generates heat energy. Generally, we don't really notice the heat because it's not enough to trigger our heat sensors within our skin, but it is technically there. And we may also hear it with our ears. It's also converted into sound energy. And here is another example, just using cherries. So up the top, it's off the ground, it's got potential energy. As it's falling, that potential gravitational energy is converted into kinetic energy, and as it hits the ground and splats, you may hear it, you may hear the splat, and so the kinetic energy is converted into sound energy and also generates a bit of heat energy as well. Fireworks. Fireworks is a fantastic example of potential chemical energy being converted into sound and light. This is a massive firework shell right here. And this is what it looks like on the inside. There's sort of like explosive material in here, like gunpowder or something like that. And the fuse burns down, and then this middle part explodes. And depending on what types of elements you have in these metal blocks here, determines what color they burn. So when the shell explodes, it generates tremendous heat, tremendous energy, and that breaks apart these miniature shells in here. And depending on what element it is, like copper or lithium or potassium or something like that, determines what color you see. So copper may burn as a bright green light. And so if you've seen a green firework, you know that in that firework shell was copper, chunks of copper that have been exploded into the sky around it. Another flow chart here as a tennis ball falls. So up the top, it's got gravitational potential energy as you hold it above the ground. When you drop it and it's falling towards the ground, there's heat energy, sound energy, and kinetic energy. You won't really feel the heat. You probably won't even hear the sound if it's just falling through air, but you will see the kinetic energy. When the ball hits the ground and squashes, it converts into elastic potential energy, and you also have heat and sound as waste. The ball bounces back up, ball bounces up again, and once again it's converted into heat, sound, and kinetic energy. Now notice the diminishing returns as energy is transformed and wasted. The reason why the tennis ball doesn't bounce up to its original height is because there's some waste. Some of the energy is wasted in terms of heat and into sound. So not all of the gravitational potential energy not all of the kinetic energy is transferred into elastic potential energy. Some of it is wasted on heat and sound.